Let's take a look at graphing the absolute value of x is less than or equal to positive 2. Look very carefully. This is the equal to part, and then this is the less than part. You need to account for both of them. We are going to do this graphically. So draw the vertical axis, draw the horizontal axis, throw in your arrows. Now look, we have the absolute value of x in blue there, okay? So that means when you draw that, it's going to look like the basic V shape that you have seen before, right? So remember, this is the absolute value of x. It's that graph. Now the right side is 2. So that becomes a horizontal line. And this is y equals positive 2 right there. Here, the y coordinate is positive 2. So then what you do is you look down to the horizontal axis. And notice I'm making this right here solid. And why am I making that solid? Because you see this includes the equal to part. And the same thing over here, look down to the horizontal axis. Take a look. If you look along this line, which is meant to be more straight, you can see that like the blue graph is definitely below the white line. And this would be like that for any value of x between the two dots. So that means if this is negative 2 and this is positive 2, you would shade everything between negative 2 and positive 2. So the solution would be negative 2 is less than or equal to x, less than or equal to positive 2. And again, let me stress, right? Like this point is included, and that because of the equal to part, and same thing with the other dot on the other side. So that's how you do this one. Friends, thank you so much for watching this far. Please remember to subscribe, like, and share, and watch all the way to the end with additional examples. Another example. So imagine x is less than positive 3. Okay, so horizontal axis with arrows, vertical axis with an arrow, say. Let's handle the absolute value of x. So that looks as shown here, and then as shown here. You've done that before. Now, this is positive 3. So think about this for 1 second. This is, in other words, positive 3 right here. This is y equals positive 3. It goes through that y coordinate. So that means throw in your arrows. And because we have only the less than symbol right there, that means when you mark this has to be a hole. And then likewise over here, you see this also has to be a hole. No solid dot. And then you look down here, again a hole. Look down there, again a hole. And then you shade everything between them. The reason is, again, if you look along a vertical line like this one, you can tell that the blue graph here is clearly below this one. That's what it means visually. That's about the negative 3, that's positive 3. And remember that x is a value that floats between them. So we have negative 3 is less than x, which is less than positive 3. That's how you think about the solution from a visual perspective. Another example, absolute value of x is greater than positive 1. So vertical axis, horizontal axis, throw in some arrow tips as usual. Okay, so first handle the positive 1. That's just a line that goes through y equals positive 1 right there. Throw in the arrow tips. Now the left side is the absolute value graph, so it's the usual V shape that you have seen before. Let me label it. Then you have the greater than symbol right here. So this is the greater than symbol only, right? This is all that you have. So what does that mean? It's like saying, look, you can tell over here that this is definitely above the blue line, and over here this is also definitely above the blue line, right? So that means you would, where does that begin? That begins right here at this value. But notice that because it's greater than, this is a hole. There's no equal to part. Same thing over here. Again, you see it begins at that hole. And then you look down to the horizontal axis, mark holes. Look down to the horizontal axis, mark a hole. And as these segments right here suggest, on this side and this side, that means you're going to shade as follows. To the left and also to the right, as shown. Right, so any value of x right here works, but also any value of x right here works. Where it doesn't work, if you grab a value of x from here, this doesn't work, right? This is no good. As you can see, if you are on the left side, then x is less than negative 1, and here it would be like saying that 1 is less than x, essentially. Or equivalently, it's like saying x is less than negative 1, or x is greater than positive 1. It's the same logical meaning. You're doing very well so far, friends. Please be sure to subscribe, like, and share, and watch all the way to the end. Another example, so absolute value of x minus 1 is less than or equal to 2. So let's do this one. Okay, axes, and then here, the fact that this is a negative 1 means you have the vertex of the graph at this location right here. I should mark this, right? This is positive 1. And then the V shape looks like this and this. Okay, then you have the 2, so you handle that as shown here. This is y equals positive 2. It's just that line, the horizontal line for y equals 2. The fact that you have the equal to part present, that means this is solid and this is solid. And now, because you have the less than symbol present, you're going to look down to the horizontal axis, look down to the horizontal axis. This is negative 1, this is 3. If you did this on grid paper, it would work out exactly that way, I guarantee. And then here, those are also solid. And then you shade between them. So reason, again, let me stress, right? If you look at a single vertical line, you see that this clearly is below this, right? This is like lower than this part. And it's like that for any value of x between negative 1 and positive 3. Just scan across. So it means the solution would be -1 is less than or equal to x, which is less than +3. Thank you so much for watching. I hope you've enjoyed it and you've learned something from it.